Good morning, class. We are looking at College Algebra, Chapter 2, Equations and Inequalities, Section 2.5, Quadratic Equations, Part 2. So we're going to continue with what we have started already. Okay. Katie invested $5,800 at an interest rate of R compounded annually in 2 years. It grew to $6,765. What was the interest rate? Reminding you of the formula for compound interest. P is the principal, R is the rate, T is the time, and N is the number of compounding that takes place per year. Therefore, according to that, P is 5,800, T is 2, N is 1 because it says annually, A is 6,765, and R is missing. So let's plug it. 6765 is 5,800 times 1 plus r to the power 1 plus r to the power of 2 times 1. So this is 1 plus r squared divided by 5,800. Take a root of both sides. So this becomes 1 plus r. This becomes plus minus the square root. Move the 1 to the left and it becomes negative 1. Now use a calculator and evaluate the left side. And of course, this is R equals 0.08 or 8%. This is a negative value. Rate can't be negative and it's out. Using the quadratic formula to solve a quadratic equation in the standard form ax squared plus bx plus c equal to 0, where a is not 0, use the quadratic formula. Everybody remembers x is minus b plus minus the square root of b squared minus 4ac over 2a. Here's a quick proof if anybody is interested using completing the square. In other words, the quadratic formula is the easier version of a completing the square. So we're going to move the constant. Here's b. Because this is a, we're going to divide everything by a because we want it to be 1. So divide everything by a. Meaning this one becomes x squared, this one becomes b over a times x, and this one becomes minus c over a. Now, we need to add, okay, so this is b over a. This is the new b we want. We want half of this, plus half of this, and I'm going to erase it later on, is b over 2a, and we need to square it and add it to both sides. When we square it, we get b squared over 4a squared. This is what we get, b squared over 4a squared. So the left side is the variable, happen to be x, and this thing, including the sign, plus b over 2a quantity squared. And the right side, okay, we can take a common factor of 4a squared. So if I multiply this one by 4a, I have to multiply this one by 4a. So this becomes minus 4ac over 4a squared. So, right, let me just quickly show you. So I'm going to multiply by 4a over 4a, and then becomes b squared minus 4ac. So take a root of the left side and the right side. This is what we get. As you know, this can be plus minus the square root of b squared minus 4ac. 4a squared comes out as 2a. And if I move this to the right, I get exactly what I had in the first place. Now, what I'm giving you, this is what I heard from one of my students, everybody. It's not mine. And she said, here's one way to memorize that. I don't know if you find this. Some of you may have heard of it. It says, there once was a negative boy who couldn't decide to go to a radical party because the boy was square. He missed out on 4 awesome chicks, and it was all over by 2 a.m. So x is minus b plus minus a squared of b squared minus 4ac over 2a. Just, something that I thought, is interesting. My students taught me. I had never heard of that, and some of you may have heard of it. If it helps, whatever helps, that you memorize the formula if you haven't already. All right, so we're going to solve this equation x squared plus 2x minus 8, where obviously a is 1, b is 2, and c is negative 8. We plug it into the formula, so we get minus b, or minus 2 plus minus a squared of b squared, that means 2 squared, minus 4 times a times c times 1 times negative 8. And so this is 4, and this is 4 times 8, 32, negative negative makes it positive 32. And so it's 36. And you know that 36 comes out as 6. So negative 2 plus 6 divided by 2 and negative 2 minus 6 divided by 2, they give us 2 and negative 4. And here's what I want you to notice. The radicand, this one, is a perfect square. That means it comes out, which causes this equation to have two rational numbers. Okay? So when that happens, you get two rational numbers. In fact, you can factor it. So when that's a perfect square, you can factor this. Okay? You want two numbers. The product is negative 8. The sum is positive 2. And this would have been a faster way of solving it. Again, ultimately, if they ask you to solve and they don't mention what method, you choose the fastest, okay? Always. All right, x squared minus 2x minus 5 equals 6. Number one, you're going to move the 6 and becomes negative 11 with negative 5. A is 1. A is 1, B is negative 2, C is negative 11. And we're going to throw it into this formula. This is positive 4. This is positive 44. They add up to 48. Now, 48 is the product of 16 and 3. You're looking for the number that is a perfect square. It's, in this case, is 16, comes out as 4. Now, it's important to know you factor the 2 out, and you get 1 plus minus 2 square root of 3, and you drop this. So it's not that you drop just the first one. I've seen sometimes students do this. They cancel this 2 out, which is wrong. Don't do that. What about this one? You have to put it in standard form. So this moves to the left, becomes positive 4x. Now a is a 2, b is a 4, c is a 2, a, b, and c. And we're going to plug it into this. So this is 16. This is 16. 16 minus 16 is 0. And you get minus 1. Notice the radicand is 0. This is 0, which causes this equation to have only one solution. They call it repeated solution because it is supposed to have two solutions, but it's a repeated solution. And that's important for everybody to know, just to show you how that thing works in case you wanted to do the factoring, everybody. This would be 2 times x squared plus 2x plus 1 equals 0. which is 2 times x plus 1 squared equal to 0. So factoring will do the job, okay? All right. Three x squared plus 10 minus 2x. We want to solve it by the quadratic formula. We move the negative 2x. And now a is 3, b is 2, c is 10. A, b, c, plug it in. And we do the math. This is 4. This is minus 120 because 4 times 3, 12 times 10 is 120. Negative sign makes it negative, and we have 4 minus 120 inside, which makes it negative 116. Now, negative 116. First of all, the negative sign, we're going to get rid of it and we change it to I. Let's deal with number 116. It's the product of 4 and 29. And again, you can do the prime factoring that I showed you before. 4 comes out as 2, 29 remains, and the negative sign inside changes to I. And now if I factor the 2 from the numerator, now what I want to do here, I want to put the I far away so everybody can see I is not under the radical. So you get rid of the 2, you change this to 3. Now, what I want to mention before we move on, sometimes they put the I in front, they write it as minus 1 plus minus I square root of 29, because they want to make sure you don't ever make a mistake of putting the I under the radical. It would be wrong. Now, notice that the radicand is negative. What you want to notice is this. This is negative. What does it mean? The equation has 2 imaginary solutions, complex solutions, which gives rise to the information known as the discriminant. What's under the radical? B squared minus 4ac has a name. It's called the discriminant. The discriminant. Solution of a quadratic equation ax squared plus bx plus c equals 0, where a is not equal to 0, is not equal to 0. When b squared minus 4ac is positive, we have 2 distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. When b squared minus 4ac equal to 0, there is one real solution, rational. Double root, they call it sometimes. When b squared minus 4ac is less than 0, no real solution, 2 complex solutions or imaginary solutions. Now, methods for solving quadratic equations, class, if they just say solve, try to factor, if it can be done easily. Square root principle, used when the quadratic equation can be easily written in that form. Completing the square, rarely the best method, but important for future topics. There are topics that we need to know, completing this square. However, don't ever use it unless you're asked to do so. Quadratic formula, used when factoring is not easy or possible with integer coefficients. Now, use the discriminant to determine the number and type of solution. So if you're looking at this, in order for you to do that, you have to evaluate b squared minus 4ac. And to do so, we are going to put this in standard form by moving the negative 1. And so a, b, c, b squared minus 4ac means 5 squared minus 4 times 2 times 1. This is 25. Minus 8, 17 is positive, and therefore 2 real number solutions, 2 irrational that are conjugate. The reason, because it's not a perfect square. What about this guy? X squared minus 6 plus 9. This is b, right? B squared minus 6 quantity squared minus 4 times a is 1, c is 9. And I hope you recognize this is 36 minus 36, 0, which makes it one real solution. Part C, of course, you can multiply both sides by 10, get rid of the decimal and do that, but just the way it is, it can be worked out. This is A, B, C. So minus 0.4 quantity squared, minus 4 times 0.3 times 0.8. So this is 4 times 4 is 16. You need two decimals, so 0.16. 4 times 3 times 8 is 96. You need two decimals, so minus 0.96. And it becomes negative 0.8. Because it's negative, no real solutions, or two imaginary or non-real complex solutions. So in short, evaluate the b squared minus 4ac to see how many solutions and what type of solutions you have. It does have an effect on graphing. You know, when you graph the function ax squared plus bx plus c, it's a parabola. When b squared minus 4ac is positive, okay, we have two distinct roots or x-intercepts. Notice whether it opens up or not. We have two of them. If we have a one single x-intercept when it's 0, it opens up or down, it touches the x-axis. And when b squared minus 4ac is less than 0, it's either completely above the x-axis or below, and therefore we don't have any x-intercepts. So again, pretty straightforward, everybody. Determine a quadratic equation given its solution. In example 18, determine an equation that has the given solutions minus 5 and 1. When the solution is minus 5, you write x equals minus 5. When it's 1, you write x equals 1. X equals minus 5 means x plus 5 is 0. This means x minus 1 is 0. So because those are the solutions, and this is 0, this is 0, their product is 0. And this is, of course, x squared. 5 and minus 1 is positive 4 plus 4x minus 5 equals 0. So this is the equation they're looking for. If the question is find the function such that its x-intercepts are that means minus 5, 0, 1, 0, then you write this as f of x equals that. F of x equals x squared plus 4x minus 5. So they might ask it in this fashion. All right, so the same thing as this one, x is the square root of 5, x is minus, see, x minus square root of 5, x is square root of 5, so x minus square root of 5 is 0. X is minus square root of 5, that means x plus square root of 5 is 0. Their product is 0. And I hope you remember a minus b, a plus b is a squared minus b squared. So you square this, and when you square this, it comes out x squared minus 5 is 0. Very straightforward, everybody. Example 19. 3 times the square of a positive number, and the key is positive, decreased by twice the number is 21. Find the number. So first and foremost, what is the number? We choose a variable. Let it be x, y, z, n, your choice. 3 times the square of a positive number, so 3x squared. So this part, 3x squared. Now decreased, that means minus. Twice the number, 2x, is equal to 20. So I think it's pretty straightforward, everybody. As long as we have the equation, we should have no problem finishing it off. We move the 21 to the left, becomes minus. And again, you can factor it by any method if it's factorable. This is 3, it's a prime number class. So I hope you recognize, for example, if you want to do that, this is x, 3x. You have no choice with 1 and 3 because 3 is a prime number. Okay. Now you want two numbers, the product is negative 21. It's 1 and 21, 3 and 7, one of them negative. You have to put them somewhere so the middle term works. When you put them in this fashion, see this negative 9x, this positive 7x. When you add them up, you must get the negative 2x, and you do. So let me actually clean up the mess. When you multiply these two and these two, it must give you this. So there are the two answers. X is either 3 or negative 7/3. When it says positive, obviously, x can only be 3. And you can check if you 3 times x, if you square that, you get 9 times 3 is 27. And then 2 times that is 6. 27 minus 6 is equal to 21. It checks. So you really should be able to check, and it's not that big of a deal. A farmer has 400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. Find the dimensions of the field if he wishes to enclose 15,000 square feet of area. So let's plug in x, y, and here's the area. So the perimeter is x and y. Normally it's 2x plus 2y, but this side doesn't need it. So 2x plus y equals 400. That's the concept of the fencing. The area is x times y, 15,000 square feet. In this equation, we solve for y, becomes 400 minus 2x. And we replace it here in order to make this one a function of one variable. So x times y, x times 400 minus 2x is 15,000. So I hope you recognize the left side as 400x minus 2x squared. I'm going to put them in descending order. So to do so, I'm going to move everything to the right because I want this to be positive. 2x squared minus 400x plus 15,000. Clearly, 2 is in common. So let's take the 2 out. We get x squared minus 200x plus 7,500. And again, if the numbers are involved, you want to use the quadratic formula, it's fine. But it may not be too bad. You want two numbers. The product is 7,500. The sum is negative 200, which makes both of them negative. 5 times 15 is 75. So try 50 and 150, both of them negative. So the answers are either 50 or 150. So let me make sure everybody understands what happens next. So either x is 50 or x is 150. So if it is 50, I want to see if it works. If x is 50 and I put here, then this must be 400 minus 2 times 50, 300. So it should be 50 by 300. If it's 150, 2 times that is 300, 400 minus that is 100. So either 50 by 300, so these are two different answers, 50 by 300 or 150 by 100. And notice both of them give you the same perimeter of 400 feet and the same area of 15,000. There happen to be two sets of answers. Here's the last question. Ryan would like to reduce a 6 by 8 inch photo such that the resulting photo will have the area half of the original photo. If he wishes to reduce the photo by the same amount on each side, by how much should he reduce the length of each side? Okay, let's figure it out, everybody. So we have an 8 by 6, and we're going to cut the same amount on each side. Same amount. When we do that, 8 becomes 8 minus 2x here. 6 becomes 6 minus 2x here. I hope everybody is clear. So we originally have an 8 by 6. And we're going to cut the same amount. How much we don't know. How about x? And so this is the size, and therefore 6 by 8 or 48 square inches is the area. We want to cut the area in half. So we want half of this. So how do we find the area? The area is the width times the length. So the width, so area is the width times the length. Here's the width. Here's the length. So 6 minus 2x times 8 minus 2x. This is the area. And we want to divide this by 2 because we want it to be half of the original size, or 24. Okay. When we multiply these two, we get 48 minus 28x plus 4x squared, because 6 times 8 is 48. 6 times negative 2x, and then negative 2x times 8, they add up to negative 28x, and these two 4x squared. Now, we are bringing everything to the right, and we're going to put it in descending order for the sake of factoring. Therefore, move the 24 this way, and becomes negative. So this is what we have in descending order. We factor out the common factor of 4. Clearly, 4 is in common. 4 times x squared minus 7x plus 6. We want two numbers. The product is c, or positive 6. The sum is b, or negative 7, negative 1 and 6. And there are two answers. X is either 1 or 6. And I hope you recognize why 6 is out, because the original size is 6 by 8. So how could you, maximum amount that you can cut is less than half of 6, okay? Less than half of 6. So this is out. So you can cut 1 from each side. So that would be the answer. Just to make sure we have answered the question, it says, how much should he reduce the length of each side? So 6, we drop 1 and 1. That means we drop 2 inches. 8, we drop 1 and 1. That means we drop 2 inches. So we drop 2 times that, or 2 inches from each side.